section 6.3, geometric random variables. This is the last kind of random variable for this chapter. Before you use the formula for this, or you need to make sure you have a geometric setting, so you need to check bits instead of bins. Bins was for binomial, bits is for geometric. So let's write that out and talk about each condition. Bits is just a great little acronym to help you remember it. So first B, what did that stand for in binomial? Binary. So which means, what does binary mean? Success or not. Okay, great. That's the same as before. I is the same as before. That stands for independent, so the probability of one event does not affect the other. S is the same as before. It's got same success rate. The probability of success is the same on every trial, but T is different. The main thing that makes it geometric rather than binomial is that you're going to continue going until you have your first success. So that you keep going. So you continue trials until first success. That's how I'll say it. Continue. T is for trials. Continue your trials until you have your first success, and that's what you're interested in the probability of. So I'm going to keep shooting baskets until I make one in. That would be a kind of geometric setting. You're going to continue until you make the success. So the formula for that, if y, if you check it's the right setting, if y has a geometric distribution, y is a random variable, geometric distribution, then the formula is this. And the formula, you're not going to memorize it. If you understand it, you just don't need to memorize it, but I want you to have it. So the probability that you have success in k trials, so y equals k, like I make it on the 5th time, I finally make the basket. So y equals 5 would be the probability you miss k minus 1 times the probability you make it. So that it should kind of, when we do the example together, it'll make more sense and you won't have to memorize all this. Now the average, or the mean, or the expected value, E of y, is, the symbol is mu sub y, so it would just be 1 over p. And let me give you an example for that. And the meaning is the expected number of trials for your first success. Is going to be 1 over p. So let's just talk about that really quick. Let's say this is from the book, but you might not have read it yet. I play the birthday game with you, and I say, okay, I'm either going to assign you 10 homework problems tonight, or we get to play the birthday game. And the birthday game is that I think of one of my friends, and you guess the day of the week their birthday is on. So what's the probability you get it right? 1/7, right? 7 days in a week. But if you miss, then I'm going to pick a different friend, and we have to start over. What's the probability each time? It's always 1/7, right? Because they're independent trials. It's important you start over again, otherwise they're not independent. Okay, so how many average should you play the birthday game? Should you take the 10 homework problems, or should you play the birthday?
One for every loss, right?
How many times on average do you think it will take you to guess it right? 7 times, right? So that's where this comes in. So the probability of getting it right is 1/7. So the mean is 7, 1 over 1/7. So should you take 10 homework problems, or should you play the game? We'll probably play the game. But of course, you never know. It might take you like a really long time, and then you'll regret playing the game, because the mean is, in the long run, you'll average out to 7 times before you get it right. So the last thing is, on your calculator, to do this, you don't even need to use this formula, as you might have suspected. If you go to second vars on your calculator, you go to geometric PDF, and you give it pk, and that will compute the probability that y equals k. And I'll show you an example how to do that. And then of course there's geometric CDF, which you still give it the same thing. PK, P is the probability of success, K is when you want that success to happen. But this will give you the probability it happens in less than or equal to that many times. So it's totally parallel to binomial PDF and binomial CDF. And that is on page 400 of your book if you want to look at the technology corner there.